Dear students, I am Pradeep Khanna, currently heading the Department of Mechanical Engineering with specialization in electric vehicles at NSUT. In this video, I am going to give you an overview of the syllabus contents, the learning outcomes, some suggested readings, and the list of practicals for the subject named Manufacturing Processes. But before delving into the content, it is pertinent on my part to familiarize you with the background, importance, and need of the subject. Now, manufacturing in the simplest possible terms can be defined as making things, and the activities of making things are called the manufacturing processes. These practices of making things have been around since prehistoric times, as it was essential for the human civilizations to make things for their sustenance and survival. It is evident that the civilizations which were good at making things flourished more and survived longer than the ones who were not good at it. The fact remains the same even today. Manufacturing is considered to be the backbone of any country's economy, as it provides the means by which a nation creates material wealth. In fact, a nation, if it is not having abundance of natural resources, must have a strong manufacturing base if it is to provide stable financial security and a high standard of living to its people. It's quite visible today that the nations which have strong manufacturing capabilities are in a commanding position over the others. Now the question comes, why this subject needs to be taught at the UG level? The answer is quite simple and obvious. Just look around. You'll find yourself surrounded by the things produced by manufacturing processes. I mean, right from a needle up to a spacecraft and everything in between is the manifestation of manufacturing processes. So it's the omnipresence of the products of these processes that make it a potential and essential topic to be included in the UG curriculum. In fact, in my opinion, the subject is so very fundamental in nature that it should be included in every discipline of the engineering. Now, looking at the vastness of the subject, it is difficult to cover the majority of commonly used manufacturing processes in one semester. The subject therefore is spread over 2 semesters by splitting it into 2 parts, namely Manufacturing Processes 1, which is taught in the 3rd semester, and Manufacturing Processes 2, which is taught in 4th semester. Also, the subject is common for the students of mechanical engineering and the students of mechanical engineering with specialization in electric vehicles. And it goes by the subject codes ME MEC 402 and ME MV MWC 402 respectively. As far as the learning outcomes are concerned, they can be counted as, number 1, the students come to know about the different types of manufacturing processes and the materials available for general applications. Number 2, the students can identify the types of manufacturing processes used to create a given product. Number 3, the students can identify the different manufacturing processes and material options available to develop a new product. Number 4, the students can select the correct manufacturing process and right material from the available options to produce the product at a lower price. And lastly and importantly, the students can undertake fabrication based projects where they can utilize the skills that they have acquired while performing hands-on practicals in the workshop. Now, before coming on to the detailed contents of the syllabus, it is important to know how it is structured. The syllabus has been divided into 5 units meant to cover different manufacturing processes and engineering materials. The manufacturing processes can be divided into 2 major categories, which are number 1, shaping operations, and number 2, assembly operation. It is necessary to mention here that besides these 2 categories, there are many other categories which fall under the domain of manufacturing processes. But the present syllabus of Manufacturing Processes 1 is focused around these 2 major categories to keep the content relevant and within practical limits from the viewpoint of its effective coverage. So let's have a look at syllabus structure. So we are discussing about Manufacturing Processes 1, which has the codes MEMEC 402 for the students of mechanical engineering and MVMWC 402 for the students of mechanical engineering with specialization in electric vehicles. Now, as far as the course structure goes, we have manufacturing processes, which is divided chiefly into, as discussed, shaping operations and assembly operations. Shaping operations are those where a desired shape is given to a starting material by a number of operations. These operations are further categorized as casting, powder metallurgy, deformation, and material removal. Casting refers to a process where molten metal is poured into a mold of desired shape. So, after solidification of this molten metal, the desired shape is taken out either by opening or breaking the mold. Then we have powder metallurgy, where the desired shape is given by using fine metal powders which are compressed under a very high pressure into a desired mold, which is made up of metal, of course. Then after that it is given a suitable thermal treatment to make the shape of the desired shape with sufficient strength and other mechanical properties. Then we have deformation, where the starting material is plastically deformed to give the desired shape. Now, this shape can be given either in the cold stage or in the hot stage. So, it is further categorized as cold working or hot working. A very common example you must be aware of is of the forging. Then we have material removal. In this case, the desired shape is given to a starting material by removing the extra material from its surface. Then we have the other category, which is assembly operation. In assembly operations, we assemble the 2 materials together to have the desired product. So, in this category, we have welding, we have soldering and brazing. Welding, you know, where the 2 pieces are joined together by using intense heat of the welding. Then we have mechanical fastening, where 2 plates, 2 parts are assembled together either by mechanical fasteners, you know, the nuts and bolts, or by rivets, or through some simple joints. Now, in this structure, if we look at now, casting is 1 unit. I told you that the syllabus is divided into 5 units. So, casting is one of the unit. Powder metallurgy is another unit. Plastic deformation processes is another unit. Welding, soldering and brazing, another unit, and mechanical fastening, of course. So, we have 1, 2, 3, 4 units covers these topics separately, and the 5th unit is on engineering materials. 5th unit is on engineering materials. In fact, unit 1 is engineering material, unit 2 casting, unit 3 is powder metallurgy, unit 4 is plastic deformation, and unit 5 is dedicated to the mechanical fastening. So as I just said, the first unit is dedicated to the engineering materials, which is rightly so, because the choice of manufacturing process and the process parameters to be selected to make a particular product will depend upon the material out of which the product is to be made. Also, the mechanical properties of the final product are dependent upon the type of manufacturing process used. So either way, the knowledge of engineering materials is necessary and will prove to be beneficial to the students. The engineering materials are classified into metals, ceramics, polymers and composites. But in the present course, the emphasis is on metals and alloys. These metals and alloys can be divided into two basic groups, namely ferrous materials, which are based on iron, and non-ferrous materials. So unit 1 is dedicated to engineering materials, where we give overview of ferrous materials and non-ferrous materials. In ferrous materials, we'll be going through the composition, properties and applications of plain carbon steels, alloy steels, cast irons, stainless steels, and some special steels like tool materials. And in non-ferrous materials, we'll be discussing the metals and alloys of copper, aluminum, tin, nickel, lead, etc. So the aim is to introduce you about these materials which are very commonly used in general engineering applications. Now, the unit 2 is dedicated to casting processes. Casting, as I have already discussed, I have already defined as a process where molten metal is poured into a mold of desired shape, from where after solidification the desired product is taken out. Now in this unit, the emphasis is on the type of casting processes. So we have broadly divided into sand casting and permanent metal mold casting. Sand castings are those where the mold is created into sand, molding sand. So molding sand plays a very important role because its properties affect the kind of casting, its quality. So in this, we'll be studying the types of molding sands, its composition, its properties and its effect on the casting produced. Then we'll deal with permanent mold casting, which covers gravity die casting, pressure die casting, low pressure die casting, high pressure die casting, and some special casting processes like investment casting, centrifugal casting, etc. And finally, we'll discuss the casting defects and their remedies, which of course is a very important aspect of castings. Next, the unit number 3 is dedicated to metal joining. Here, metal joining means we'll be discussing about welding and soldering and brazing. Now, welding, as you know, is a process where the metals which are to be joined are melted at the interface and are joined. Now, in this case, in this chapter, we will be discussing different types of welding processes based on their heat source, like gas welding, arc welding, solid state welding. Now, we will be going into details of gas welding, the types of flames and the properties of different flames and their applications. Then we go to arc welding processes, where we shall be discussing shielded metal arc welding, MIG welding, etc. We will go for with the welding consumables, where we will be dealing with the type of electrodes and other consumables which are used while welding. Then we will discuss the solid state welding, which is one of the important solid state welding is friction stir welding. And finally, we will be dealing with the welding defects and their remedies. So this was unit 3. Unit 4 is about powder metallurgy. Powder metallurgy, as we discussed, where fine metal powders are processed by first compressing them into the desired mold and then heating them to a certain temperature so that they acquire the desired properties. In this case, we shall be discussing the complete process of powder metallurgy and their comparison, their applications and their comparison with the conventionally produced products. So, unit 5 is dedicated to the plastic deformation processes, which include rolling, extrusion, forging, etc., where we will be discussing the cold working processes and hot working processes. Then we have sheet metal work. Sheet metal work is where we deal with metal sheets and the different tools which are used to give different shapes and in making different types of joint with metal sheets of a specific thickness. Then we have bench work and fitting. This involves the use of hand tools in giving different shapes to the starting material by removing excess of material. Remember, this has to be done by the use of hand tools. Here we will be looking at processes like sawing, chipping, scraping and thread cutting, internal as well as external. Remember, these two topics are covered in your class workshop practicals also. These are some of the suggested readings. These are 5 suggested readings where this first, second and third. These 3 cover comprehensively the manufacturing process 1 and manufacturing processes 2, both of them. These number 3 and number 5, they are available in volume 1 and volume 1. So, they will be dealing with manufacturing processes only, and if you need to have a detailed study of the hand tools which are used in this process, then this 5th book is good at that. Remaining books are good in the pictorial depiction of the different processes. In my opinion, all are good in quality. You can refer to any one of them. These are the list of practicals. These 3, the first 3 are related to the fitting shop, where the student is supposed to carve out a the given shape on a starting material with the help of hand tools. So, these 3 exercises are for that. Then these 3, 4, 5 and 6. This is related to welding. So, here the students are trained on creating and stabilizing a metal arc with the help of simple tools. Then in making different joints. So, you will be taught, you will be trained about making a straight line weld bead and making a weld joint. Then number 7 and 8 is for sheet metal shop, where the students are supposed to cut different geometrical shapes on metal sheets and making simple sheet metal joints with the help of hand tools only. 9th and 10th is for foundry. Here it is related to casting. Here the students will be trained on how to make sand molds for a given shape. So, this is about list of practicals. So, dear students, I hope this video gives you the requisite amount of information for a good start. Thank you and good wishes.